Welcome to the National Science and Math Quiz. Today we bring you the 6th 1A stage contest featuring Nifa Senior High School, St. James Junior Seminary, and Adisadel College. I have here Adisadel College represented by
Apiaku Bisamo, final year.
Benetini Akwibran, final year.
Preamble to all schools. Explain the term I give you. Pyramid of numbers. Yes, Bennett.
It is an ecological diagram that shows the total number of organisms at each trophic level in a community or an ecosystem.
Okay. Name the structure in the nucleus that condenses during cell division to form chromosomes. Yes, Apia Kubi.
Chromatin.
You're right. Adisadel, why and HNO3 the same, despite the fact that they are different compounds? Yes, Bennett.
HCl and then HNO3 are both strong acids which dissociate completely in solution. They ionize completely in solution, and so the same energy is required to ionize both of them.
Yes. Next is a single question to all three schools. I come to you, you give me a right answer, then I move on to the next school for the next right answer. No bonus. This is the question. State one of the main characteristics of liverworts. Adisadel. Yes, Bennett.
They have unicellular rhizoids.
Adisadel. Find the length of a diagonal of a square whose side is 10 centimeters long. Yes, Apia Kubi.
10 with 2 centimeters.
You're right. What is the main difference between oleic acid and stearic acid? Yes, Bennett.
Oleic acid is unsaturated, whereas stearic acid is saturated.
Yes. Preamble to all schools. And you have 30 seconds also. The Coulomb constant is approximately 9.0 times 10 raised to the power 9 meter per farad. That's the preamble. Please, did you find the charge on a metal sphere of radius 0.05 meter, which is at a potential of 900 volts? Yes, which of you? Apia Kubi.
5 times 10 to the power minus 9 coulomb.
Yes. With the same preamble, your major question. Find the radius of a metal sphere which carries a net charge of 5 nanocoulombs. Yes, Apia Kubi.
5 meters.
You are right. Round 2. In this round, I'm going to present all three schools with a single question, the problem of the day. From the time I ask you to begin, you have 3 minutes in which to present an answer. The problem of the day is worth 10 points. Let's turn over our sheets and read the problem of the day together. Problem of the day. You are provided with a solid mixture of Na2CO3 and NaHCO3, for which you are required to determine percentage composition by a volumetric method. State how you would perform the exercise in a science laboratory to obtain the titer values. You are not required to go beyond obtaining the titer values. Assume that all glassware, apparatus, and chemicals needed are available. Contestants, this is your problem of the day. You may now begin. pick up your answers and present them on the board. The contestants have presented their answers. Before we award the marks, let's look at the suggested solution from our consultants. Given a solid mixture of Na2CO3 and NaHCO3, and the requirement for the contestants was to determine the percentage composition using a volumetric method and to tell us how this exercise is going to be done in a science lab to obtain tighter values. And it goes further to say that all glassware apparatus and chemicals needed are available, giving the impression that it must be practical indeed. It has to be practical. All right, so this is how to go about it. In a weighing bottle or in a small watch glass or small beaker, weigh out a calculated amount of the solid mixture on an analytical balance. Transfer the solid into a clean beaker and add about 50 centimeter cubed of deionized or distilled water. Stir with a glass rod until all the solid is dissolved. Transfer the solution to a 250 or 100 centimeter cube volumetric flask through a funnel and with the aid of a glass rod. Wash the beaker, the glass rod, and funnel into the volumetric flask. Add deionized water or distilled water to the volumetric flask until the meniscus gets to the mark. Stopper or cork the flask and shake it for about 10 to 15 seconds in order to obtain a uniform solution. Fill the burette with standardized HCl or HNO3 or H2SO4 solution. Pipette 25 or 20 or 10 centimeter cubed of the prepared solution into a 250, that is for 25 and 20 centimeter cubed pipette, or 100 centimeter cube for the 10 centimeter cubed pipette, conical flask. Now, this section can be varied, so I'm going to first talk about the first one way of doing this. So, you can add phenolphthalein and titrate to a colorless endpoint and note the volume V1, that's the titer, right? Add methyl orange to the same solution and titrate to an orange endpoint, note V2. Now repeat until you get consistent V1 and V2. Those are the titers. All right. Now, if you didn't want to do it in a single step like that, then what you could do was when it came to the point of the titration, you can add phenolphthalein and titrate to a colorless endpoint, repeat until consistent titers are obtained. You can call that the average V1 prime. Then pipette a fresh aliquot of the solution and add methyl orange and titrate to an orange endpoint. Then you repeat until you get consistent titers for average V2 prime. Then you are ready to go. So you see, you had a choice how to go about it. All right, so this is what was expected for the full 10 points. The contestants. Let's start with the Buakwa State. That was being performed, but you didn't get too far. You only talked about one titration using phenolphthalein. That will not get you the full composition of the solution, right? But for the experimental steps that you mentioned and for the phenolphthalein titration, I'm giving you 5 out of 10. So Gakofe, you knew exactly what to do, but yours can be done without any lab. It is so theoretical. Extremely theoretical. You could even do it right here on stage. But you knew what to do. I'm giving you 6 out of 10. At Adisadel College, you also knew exactly what to do. Yours had a slightly more experimental note to it than Sogakofe. But you see that the level of detail required, that's not what you have there, right? Okay, so I'm giving you 7 out of 10. That's the end of the problem of the day and the end of round 2. You may pick up your notepad. Round 3. In this round, I'm going to present you with statements. When you receive your statement, please consider the statement carefully and let me know whether it's true or false. If you are right, 2 points. If you are incorrect, you lose a precious point. You may choose not to respond, in which case the statement becomes available to the 2 other schools. When a school ranks and answers correctly, 2 4 points. If the answer is incorrect, it fetches the penalty point. Best wishes to all schools. The graph of y is equal to x cubed minus 1 has 3 x-intercepts. Bennett?
False.
Yes. Element with atomic number 20 belongs to group 2 of the periodic table. Bennett?
True.
Yes. Final round, round 4. In this round, I'll be reading out clues. Your objective is to solve the riddle. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. I belong to a line of nobilities. In our kingdom, we go by our common names and not titles. We are not sociable, so quite often we do not know what is going on in our kingdom. I am a colorless and odorless gaseous element with atomic number 18. Yes, Apia Kubi. Bennett.
Argon.
Yes, it's argon. I am used to refer to the positional arrangement of the parts of a flower within a flower bud before it has opened. I am also a widely used strategy across all forms of hypometabolic organisms. I am used to describe the state of inactivity in certain invertebrates and vertebrates. I take place during times of heat and dry. Bennett?
Estivation.
Yes.
For our first runner-up, that's Adisadel College. The prize of 30,000 Ghana cedis goes to the school, 3,000 Ghana cedis go to the teacher, and then 3,000 Ghana cedis goes to the contestants. Adi School.